So grade 10, I'm going to take you through how to analyze our data from that experiment we did yesterday using a template that I've made. And you should have downloaded this hopefully onto your desktop because when it's assigned to you from Google Classroom, the only way you can actually work with these spreadsheets properly is to download them onto your desktop and then work with them actually in the Excel application on your Mac. If you haven't installed Excel on your Mac, you need to go to self-service and do that now because it's essential that you have Excel on your computer for senior math and sciences. So once you have caught up with getting it installed, this is what you actually have to do. First of all, you're going to turn on the auto save just in case. Now, because this is an application and then it has to sync to the internet and back, that means you have to sync it to your Microsoft account. So you click this autosave thing here, and it goes, hang on, you want to autosave this spreadsheet. Now change the name. If it isn't, you need to change that name to your name there, but you need to tell it where to save. Now you actually have a OneDrive account with our school Glasshouse thing on it with Microsoft. It's exactly the same username and password. So select that OneDrive account there and go upload. And this will actually upload this to your school Microsoft account. Now I don't want you using the Microsoft account all the time, but it's very handy to have it turned on as an autosave feature so that you never lose any work. So do that first no matter what. The next thing we have to do is figure out how to put in our data. Now, I've set up this basic template here, just like I've taught you in previous years, where you have to have a table that's got your independent variable and your dependent variables. And then next thing you have to try and do is try and figure out where do you put them on the table, okay? It actually gives you an awful lot of hints here, and we're going to zoom in and have a look at it, and you're going to fill it out as we go. So if you zoom in, this is set up so that you can basically use it with most experiments as is. Don't worry about this yet, we'll talk about that later. The next thing we're going to do is we're going to try and give the graph a title. So if you have a look in here, it's giving you an awful lot of pointers. So in this case here, your graph title is going to always reflect what you changed and what you measured, your independent variable and your dependent variable. What did we change? We changed the temperature that the yeast was growing in. What did we measure? Well, we actually measured the rate of respiration, or fermentation in this case, which is a type of respiration. We measured that rate as our dependent variable. And how did we measure it? We measured it in how many bubbles of CO2 it released every minute. So now we're going to make our title reflect that. So I want you to double click and we'll just highlight all of that and we'll type in a new title. So independent variable was temperature versus, should put a little b there, or effect on, and respiration. The next thing we're going to do is we're going to give a title to, I should have put here variable here. This is my independent variable here, and this one over here is my dependent variable. I'm going to give them a title. Now, we've already summed up what our independent and dependent variable are here. You just now have to tell the graph for what is the columns and what is the rows. Now the columns here, let's start with the rows. Trial 1, 2, 3, 4, 5. So we're measuring the same thing over and over again in different trials. That's going to be our dependent variable, the thing that we're measuring. What are we measuring? We're measuring respiration. Okay, but I'm going to be a little bit more descriptive here. Respiration, but we're doing it in bubbles per minute. If you can put in your title not only what you're measuring, but the units that you're measuring it in, That is really, really important. So put in your title for your columns and for your rows, the units after it. That's important because that means that it leaves these little bits here open to being purely numbers, okay, if possible. So put that in there. Then up here, if we've done respiration down the side, then this is going to be our temperature, okay? So notice how we have 10 different columns here. That means I've actually set this template up for up to 10 different independent variable groups. So we could have gone like 0 degrees Celsius, 10 degrees, 20 degrees Celsius, 30, 40, 50, 60, and on and upwards. We could have had a whole heap of different temperature groups, okay, or test groups. But in today's case, or yesterday's case, it was 2 different groups that we had. We had one at 21 degrees Celsius and one at 35 degrees Celsius when I went and remeasured the temperature. They were my 2 independent variable groups because each group had a different set temperature. Now up here, it's asking you for another title here, one that encompasses all of those groups or describes all of those groups, what they have in common. What do they have in common? They have in common temperature. And again, like I did before, put in your units. What are we measuring that in? Degrees Celsius. Do not put it in here. If you do, then that turns this into text. Now it's really important, if you can in Excel, to keep anything that you might be graphing in as numbers rather than text if possible. Okay? As soon as you put them in as text, all it can do is basically bar graphs. But if you can put them in as numbers, that actually opens up your options a lot further. And I'll show you a little bit about that in future lessons. But for now, I just want you to put it in as 21 and 35. And the rest of these guys, we actually get to basically ignore. Okay? Now, if they bug you, this is how you ignore them. You take this column here, press Shift, go all the way over here to K, and then I want you to hide them. Go right click, hide. And it'll get rid of them, but it won't kill them or anything. Now, nothing fits very well here in these last 2 columns. So again, you can go Shift, click the B, hold down your Shift key, click the C, and it will highlight both those columns. And then you can actually come over here until it turns into that little funny little line with the arrows horizontally. And you can stretch them out to however big you want so that it looks nice again. And those other columns are hidden in here and you don't have to look at them. Okay? So get your graph set up, or your table set up to this point first, and then come back and look at the video again. Okay, now we're going to put in some data. So we've got our 2 groups here, 21 and 35. We had a lot more than 10 trials though. So what we're going to do is we're going to add in some extra, well actually no, I'm not going to worry about it today. I was going to add in some extra rows here for extra data. I'm just going to take some of the data we had yesterday and pick some of them out just to put them in here so we have enough for this scenario. So let's have a look. Okay, so here's the data from several combined groups there. Okay, we actually had the girls of one group who were measuring just near me, that's their data there, and they had quite consistent data. We can also see here that some of these groups down here had quite consistent data. However, across the board, you guys didn't have very consistent data. And the funny thing is, you were all using the same solution that I made up. And yet all of you seem to get different bubble counts. So that goes to show you how easy it is to try to get different amounts and different measurements with the same starting solution. The only thing here I can see that might be an issue is maybe you guys had different amounts of yeast solution in each of your pipettes. Either that or they were at different temperatures, which would increase or decrease the rate of respiration. Show you how well Excel works and helps us to interpret this. Okay, so first of all, I want you to add this data into your spreadsheet and catch up with me there, and then we're going to explain it. Okay, I hope you've caught up. Now, once you've put this in here, the first thing it does is asks you to put beside it an X that really indicates something, anything that is completely way out of the ordinary and really needs to be excluded because it is so different from the rest of the data. Now, I don't see anything that's jumping out. Yes, they're not all exactly the same, but it's not like we have something like 100 or 80 there compared to like 10. They're all relatively close to each other, so I'm actually just going to leave them in right now. But if I did have one that was, he's definitely not supposed to be there, all you do is you double click on that number there and you put an X beside him. Now all of a sudden Excel sees him as text, and you'll notice that my average changed then as well. I'm going to undo that so you can see. Watch the average. When he's a number, there's the average, 14.5, which is quite higher than what we'd think it should be. As soon as I put an X there, the average excludes that number, so because it's seeing it as text, and it changes the average. So I haven't actually deleted my raw data. I can still see what the measurement was, but with the X there, it doesn't now become part of my average. It's ignored by Excel. Okay? So make sure you do that with any really obvious outstanding outliers, but we don't have any for today.